Hello everyone and welcome to our video today where we're talking about biochemistry chapter 5, lipids. So there's not a lot of things that I took out of this chapter. It's pretty low yield, but there's also some, basic concepts that are important, but not too many details in my personal opinion. So let's get started. So we have phospholipids, okay? And so phospholipids are a phosphate with an alcohol creating your polar head, and they have a phosphodiester linkage to a fatty acid tail, which is nonpolar. So we've seen what the lipid bilayer looks like. I can draw that out right now, actually, to be sure. So this is actually would be the head. This would be the polar head up here, and this would be the fatty acid tails, and this would be phosphodiester linkage right here, okay? And so you would create your phospholipid bilayer, which really is looking like this, okay? Just very roughly, this is what your phospholipid bilayer looks like, okay? All right, so next, not the best drawing I've ever done, so we'll take that off. All right, so next, let's note that phospholipids are classified by their backbone. So glycerol phospholipids have a glycerol backbone. Sphingophospholipids have a sphingosine backbone. Now you could at this time look these up, be able to recognize them. I did not personally draw them out. I can recognize them though, but I did not draw those out. But just know that they're classified by their backbone. So glycerol, you would see a glycerol molecule in there. Sphingolipid, you would see a sphingosine molecule in there. And there are other types, but like I said, I did not draw those out, but you can look those up right after this video. So next we have an example of saturated versus non-saturated fats, okay? So saturated means it is saturated with hydrogen bonds. That's the most important part, is saturated with hydrogen bonds. So here we see just a, linear carbon chain, but we have each carbon has the maximum, all the extra bonds are bonded to a hydrogen. And so it has a maximum number of hydrogen bonds in a saturated fat, okay? Lipid. Then we have non-saturated, which is something like this, that the bonds, sometimes they're double bonds, and this creates kinks in our lipids, okay? So we have some, some hydrogens for sure, but it's not saturated with hydrogens, and that's the difference, okay? And this plays a role again in for example, the kinks is really an important feature or characteristic of the non-saturated lipids, okay? Then we have signaling lipids, and we have terpenes and terpenoids. Those are examples of signaling lipids. And then we also have steroids. Steroids, for example, cholesterol, and this is what a steroid looks like, just a vague structure to recognize that. And then we also have prostaglandins, which regulate CAMP levels. Another important point in this chapter is the fat-soluble vitamins are A, D, E, and K, okay? So next, let's go over here. We have a couple more things to cover. So we have energy storage, right? So we know that we use fats for energy storage. So we have triacylglycerol, which is the storage of fatty acids, and it contains one glycerol with 3 fatty acids that are connected via ester bonds. So if we look at this, for example, here we have our glycerol molecule. I'm hoping you can see this. Here we have our glycerol molecule, and then we have our fatty acid, okay? That's just a chain of, just a very light drawing of just a fatty acid tail, okay? So we have a glycerol with 3 fatty acid tails, okay? And they are ester bonds, the tails to the glycerol molecule, all right? Let me put this back so it's not wobbly. All right, Then we have adipocytes, which are animal cells used for the storage of large triacylglycerol molecules. Okay, adipocytes. Then we have over here, we have our soaps. I believe I can move this closer at this point. All right, we have soaps, which are salts of free fatty acids. We have saponification, which is the ester hydrolysis of triacylglycerol using a strong base. So I would definitely recommend doing this reaction. So again, saponification is the ester hydrolysis, which we've covered in the organic chemistry videos, but ester hydrolysis, right, breaking of water of triacylglycerol, which we just saw up here, using a strong base. And we will go over strong bases in one of the chemistry videos. And then finally here we just have micelles, and they can dissolve lipid-soluble molecules. So we saw our phospholipid bilayer, right, that just had this type of structure. And the reason it had such like a linear structure is because there was two fatty acid tails, right? So you can just kind of look at that as being this, as just being a rectangle, right? But for micelles, they only have one fatty acid, so like that. So what happens is they start to go in like this, right? Because this is more of a cone shape compared to the rectangular shape when you have two fatty acid tails. So that's micelles, and basically the important part about micelles is it's a very good carrier for certain things, right? Because we know the tails are nonpolar, so the nonpolar molecules can be carried inside this micelle. And then we have polar heads around that allow it to be, for example, through in the water in an aqueous solution with the polar heads there. So micelles are very good like carrier molecules, and a lot of soaps. This is how soaps work as well. They kind of encapsulate the dirt per se, and they get washed away with the water, but the actual molecule and piece of dirt is inside that centerpiece because it's nonpolar properties. Excuse me. So yes, thank you for tuning into our lipid video. Like I said, kind of a low yield chapter. I didn't pull too much out of it. Like we said, you could definitely look up the different types of phospholipids, glycerol phospholipids, sphingolipids, as well as some others. But overall, these are the important pieces that you should really understand a good foundation for. So as always, if you have any questions, put them below. And if not, we'll see you in the next video.